Electrolytes are the substances which conduct electricity either in their aqueous state or in their molten state. Materials are classified into three types: conductors, insulators, as well as semiconductor, depending upon their conductivity. When you consider Ohm's law, the resistance of any electrolytic solution is directly proportional to the length and inversely proportional to its area of cross section. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Today I am going to discuss the second session of chapter Electrochemistry. Second session of the chapter Electrochemistry. In the previous session, I discussed about, that is in the first session, I discussed about what is electrochemistry and the importance of electrochemistry, oxidation and redox reaction, conductors and its type, electrolytes and its type. I discussed about what is electrochemistry, what's the importance of electrochemistry, and three types of chemical reaction: oxidation, reduction, as well as what? Redox reaction, conductors and its types, as well as electrolyte and its type. Today, in this session, conductance of electrolytic solution, electrolytes, conductivity, as well as resistance, cell constant, conductance, conductivity, and numericals. I am going to discuss about one type of conductivity, that is what? Molar conductivity. Molar conductivity. Okay. This session I am going to deal with conductance of electrolytic solution, resistance, cell constant, conductance, conductivity, numericals, as well as what? Molar conductivity. Conductance of electrolytic solutions. The first topic, conductance of electrolytic solutions. What are electrolytes? Already you know that electrolytes are the substances which conduct electricity either in their aqueous state or in their molten state. So, electrolytes. In electrolytes, we have two types of electrolytes: strong electrolytes as well as weak electrolytes. Strong electrolytes are those which undergo complete ionization. Weak electrolytes are those which undergo partial ionization. Under conductance of electrolytic solution, first topic you have to talk about resistance. Resistance is denoted by capital R. Resistance is a measure of hindrance for the flow of electricity. Resistance is the hindrance for flow of electricity. For the flow of electricity, some hindrance is shown by the electrolyte. That hindrance is known as what? Resistance. Resistance is measured in ohm. It is a ohm. Resistance is measured by ohm. According to Ohm's law, the resistance is directly proportional to length as well as inversely proportional to area of cross section. So, when you consider Ohm's law, the resistance of any electrolytic solution is directly proportional to the length and inversely proportional to its area of cross section. So, for electrolytic solution, L represents the difference between the two electrodes. Okay. If it is solid material, it is length of that electrode. If it is electrolytic solution, so L is the distance between two electrodes. L is the distance between two electrodes. Therefore, according to Ohm's law, resistance offered by a substance is directly proportional to length and inversely proportional to area of cross section. If I remove the proportionality sign, so rho into L by A, rho into R is equal to rho into L by A, where rho is called as proportionality constant, or also known as specific resistance and also known as resistivity. What is rho? Rho is called as specific resistance or resistivity or proportionality constant. That is R is equal to rho into L by A. When length is 1 meter and area of cross section is 1 meter square, R is equal to rho. When length is 1 meter, area of cross section is 1 meter square, R is equal to rho. What is rho? Rho is called as proportionality constant or specific resistance or resistivity. So, when length of the material or the distance between two electrodes is 1 meter and the area of cross section is 1 meter square, R is equal to rho. Therefore, what is resistivity? Resistivity of the substance is resistance of the substance when its length is 1 meter and area of cross section is 1 meter square. 1 meter square. So now students, the resistivity, how can you define the resistivity? The resistivity is defined as resistance offered by a substance or a material when length is 1 meter as well as its area of cross section is 1 meter square. Length is 1 meter as well as its area of cross section is 1 meter square. The resistance offered by the material is called as resistivity. Therefore, the resistivity is defined as it is the resistance offered by the substance or a material whose length is 1 meter as well as area of cross section is 1 meter square. Its unit can be derived by rho is equal to R into A by L. R is ohm, unit of resistance. Area is meter square, it is meter. Therefore, it is ohm meter. It is ohm meter. Ohm meter. Okay. The resistance, resistivity unit is ohm meter and resistivity is denoted by rho. Okay. Next, when you consider cell constant is denoted by G star. Cell constant is denoted by G star. Cell constant is denoted by G star. What is cell constant? Is the ratio between length and area of cross section. It's the ratio between length and area of cross section. Therefore, cell constant G star is equal to L by A. The ratio of the distance between the two electrodes L to the area of cross section of the electrode is known as cell constant. Cell constant is denoted by G star. What's the formula for cell constant? Cell constant G star is equal to L by A. L by A, where L is the length of the electrodes as well as A is the area of cross section between area of cross section of the electrodes. Next to conductance. Conductance is denoted by G. Conductance is the measure of ease with which electric current flows through the substances. It's a capacity of a material to allow electric current to through it, that is known as conductance. Conductance is reciprocal of resistance. Conductance is reciprocal of resistance. Conductance G is equal to 1 by R. That is, conductance is reciprocal of resistance. Reciprocal of resistance. Therefore, the unit of resistance is ohm. The unit of conductance is ohm inverse Simon or mho. Conductivity. Conductivity is denoted by kappa. The reciprocal of resistivity. Reciprocal of resistivity is called as conductivity or specific conductance. Alige kappa is equal to 1 by rho. Kappa is equal to 1 by rho. Rho is equal to R into A by L. R into A by L. Alige kappa is equal to 1 by R into L by A is equal to G into L by A. Therefore, when L is equal to 1 meter as well as A is equal to 1 meter square, kappa is equal to G. Conductivity of a material in Simon per meter is defined as conductance when the length of the conducting material is 1 meter. The length of the conducting material is 1 meter and its area of cross section is 1 meter square. Or if you want to define conductivity in another way, conductivity of a solution at given concentration is defined as the conductance of the solution contained between two platinum electrodes of unit area section, cross section kept apart by a distance of 1 meter length or unit length Okay. Next, in this table, I had given all conductance of electrolytic solution. The conductivity values of some materials are 298 Kelvin. Sodium 2.1 into 10 to the power of 3. Pure water 3.5 into 10 to the power of minus 5. So, we listed the conductivity of some of the materials like sodium, copper, silver, gold, iron, graphite and insulator, glass, Teflon. So, aqueous solution, pure water, HCl, KCl, 0.1 molar NaCl, acetic acid KCl, semiconductor, so CuO, Si, germanium. So, I had given list. Please go through that. No need to by heart this. Just for a reference, the conductivity, how the materials have the conductivity values. Okay. Next, conductivity. How this conductivity depends on certain factors. Conductivity depends upon The nature of the conductor. And conductivity is increases with increase in concentration. Why conductivity is increases with increase in concentration? Because as a concentration increases, since the number of ions per unit area increases, conductivity depends on the temperature and pressure at which the measurements are made. Materials are classified into conductors, semiconductors as well as insulator depending upon their conductivity value. Materials are classified into three types: conductors, insulators as well as semiconductor depending upon their conductivity. If they have large conductivity, they are called as conductor. If they have very less conductivity, they are called as what? Insulator. If it is between conductors and insulator, they are called as what? Semiconductors. If they have large conductivity, they are called as conductors. If they have low value of conductivity, they are called as insulator. If it is between that of conductors and insulator, they are called as what? Semiconductors. Now I'll go to the problem session. Please read the question. 1 molar solution of salt surrounding 2 platinum electrodes 2.1 centimeter apart, 4.2 centimeters in area, found to be offer a resistance of 50 ohm. Calculate the conductivity of the solution. If you want to find out conductivity is kappa. Kappa is given by L by A into 1 by R. What's the formula to find out conductivity? L by A into 1 by R. What's the value of L? L is 2.1. Area of cross section is 4.2. 1 by 1. Resistance is 1 by 50. So if you calculate this, you'll get answer 0.01 ohm inverse per centimeter. Ohm inverse can be written as what? Cyber. So what's the formula to find out specific conductance or conductivity? The specific conductance or conductivity is calculated as well as it is denoted by kappa. Kappa is equal to L by A. Kappa is equal to L by A into 1 by R. Molar conductivity. Molar conductivity is denoted by lambda m. What is molar conductivity? Molar conductivity is due to all the ions present in 1 mole of an electrolyte dissolved in a liter of solution. So molar conductance lambda is equal to kappa into V. The molar conductivity is due to conductivity due to all the ions present in 1 mole of an electrolyte. Lambda m is equal to kappa into V. V is the volume in liter containing 1 mole of an electrolyte. C is the concentration of solution mole per liter. Therefore, lambda m is equal to kappa by C. C is the concentration, V is the volume. In the above equation, kappa is expressed in Simon per meter. The concentration C in mole per dm cube. Therefore, unit of molar conductivity lambda are Simon meter square per mole. Unit is Simon meter square per mole. Okay. So it may be noted that 1 mole per meter cube is equal to 1000 liter per meter cube into molarity mole per liter, and hence lambda m Simon meter square per mole. So m is equal to molarity of the electrolyte solution. M is the molar. How the lambda m and kappa are related with each other? Lambda m is equal to kappa into V. What is molar conductivity? Molar conductivity is the conductivity due to all the ions present in 1 mole of an electrolyte. Similarly, equivalent conductivity lambda EQ. Okay, so there molar conductivity is due to the conductivity due to ions present in 1 mole of an electrolyte. Here 1 gram equivalent of an electrolyte, 1 gram equivalent of electrolyte in VML of solution. Lambda EQ is equal to kappa into 1000 divided by n, where n is equal to normality. What's the difference between molar conductivity as well as equivalent conductivity? Molar conductivity you have to consider 1 mole of an electrolyte. Equivalent conductivity you have to consider 1 gram equivalent of electrolyte. 1 mole equivalent of electrolyte. That's the difference between molar conductivity as well as what? Equivalent conductivity. Therefore, next session I'll come up with what are the factors affecting this conductivity. How molar conductivity and equivalent conductivity affected by some factor, Kohlraasch law, as well as what are the applications of Kohlraasch law. This is the next session. Therefore, student, this session I discussed about all the cell constant, specific conductance, conductivity, resistivity, as well as two types of conductivity, molar conductivity as well as what? Equivalent conductivity. Next session, I'll come up with different topic. Until that, goodbye. Have a nice day. Thank you.